Lesson 18, Enhance the client connectivity in a data guard environment. After completing this lesson, you should be able to configure client connectivity in the data guard environment. And also, you should be able to explain transaction guard and application continuity. And also, how to implement failover procedure to automatically redirect client to new primary database. So let's talk about connectivity in the data guard environment. In the data guard environment, we may have connections to physical standby databases for the reporting operation. And also we may have connectivity to logical standby database for reporting and other operations. And definitely we have connections to primary databases. So in each host where primary database is running, or another host where standby databases are running, listener support connection request, and eventually support the establishment of connections. So when user requests connection for transactions, then the listener running out of host where primary database is running, it receives connection request, and it eventually spawns server process to let user connect to instance through server process. And also, if a user that is performing the real-time query, then this user will connect to listener running out of a physical standby database with the active data guard real-time query feature enabled. So just like this, depending on your workload separation, your workload will maybe running out of a primary or physical standby and logical standby. But think about switchover and failover. So what are the ways to redirect your workload to a new database role? In the data guard environment, that's the consideration. So some of the issues when managing client connectivity in a data guard environment. As I said, databases reside on different hosts, and listeners running on database servers, the work for connections, eventually to establish sessions. And also, client must to connect to correct database for reporting, for analytic queries, for backup operations, for DML transactions, and so on. And also, primary and standby databases can alternate host with the switchover and failover operation. So since database role can be changed, your workload must be redirected to a database with a new role. So far, we mainly focused on database role change in case of a planned maintenance, and also in case of unplanned outage. But what about your client? What about your application? That's another level what we have to take care as well. If a client sends the connection request to wrong host, they may be connected to wrong database or receive an error. Client must automatically reconnect to the correct database in the event of a failure. So what is the best way to prevent the client from connecting to wrong database? The best practice is it's better to use database service to prevent client from connecting to wrong database in the data guard configuration instead of using SID. Especially role-based service will be perfect. In the standalone environment, you can simulate a role-based service by using the event-based trigger or after a startup trigger. So we can use a trigger to start service based on new database role. In the clustered environment, we can create service and we can assign role. So role-based service can be created. So when database role gets changed, Clusterware automatically identifies service that must be running and then start service in the appropriate database with the appropriate role. And database services register with the listeners. Client connect to database services instead of database instances. If a customer is currently use, or if you are making connection using SID to make connection to database instance, then that's not flexible, and also it's very hard to automate a client connection to a new database role. And listener use a registration detail to determine which instances support a particular service a particular moment in time. So service registers all the listener registers all the services based on dynamic service registration and also static service registration. When request comes, listener checks whether service exists to support a connection to the current instance. So listener knows how to handle connection request when you are using service. And listener then redirect connection request to a correct instance, otherwise the appropriate error is returned. So in the data guard environment, how to create service. Depending on your environment, if a data guard is configured in the clustered environment, then we're going to use SRVCTL, server control utility. If a data guard is configured in the standalone environment, then we're going to use DBMS_service package. So when you create service, you provide a name and network name, and also you add a set of attribute to enable TEF and also to manage load. So we can actually set a load balancer goal. And we can also enable fan. We can also enable distributed transaction processing. So when you create service, you can add several attributes to enable many of the features. Especially in the clustered environment, you can activate more features with the several attributes. So here's an example in the standalone environment. So in the standalone environment, you can create service, in this example, data guard prod. And also we have a failover method basic, failover type select. And these are the attributes of a TAF, transparent application failover. So it supports session failover feature. And also you create service called data guard real-time query. And that's a name you provided. So as a name tells, this is to support active data guard instance connection. So we have a data guard real-time query, and also we can create logical database service and also snapshot standby database service. So in each database, you create service that can be running. For example, in the Boston database, in our practice environment, we can start DG-prod. We can also start DG-RTQ. We also can create DG logical standby. We can also create DG snapshot. But you activate only one of the services. You start only one of the services based on your database role. Same thing, in the physical standby database, you create all of the possible services, but start only one of the services based on your current database role. That's what we can do. So here we have connecting client to correct database. Use a database event trigger to ensure that client connects to a database in the data guarded environment that is in the correct state and role. In the standalone environment, we can use event trigger to automate starting up of a service based on current database role. So we can use the after startup trigger, or we can use after DB role change trigger. So you can use one of the two possible options. Your trigger will start service for primary database, service for real-time query, and service for snapshot standby database for testing, and also service for logical standby database. So here's an example. You can create trigger, trigger for to start services. In case of the role change. So this is the after DB role change trigger. And you can also create after startup trigger as well. So if a database role get changed, or if a database restarted, double check with the database role and then start service appropriately. For example, select database role from $, database. If a database role is a primary, then start data guard prod service. If the role is a physical standby database, then start DG real-time query. And also, if a role is a logical standby database, then start the DG logical standby. And also, snapshot standby as well. Now, how client can connect to database instance? Client can define net service name in the centralized location using LDAP or local network configuration file like a tnsnames.ora or easy connect method. So this example, we have a prod. This is to connect to DG prod, and we have a RTQ net service name. It is to connect to DG RTQ. And also we have a list of servers, meaning that this service can be running out of a database on host 01 or database on host 03, depending on database role. Same thing for the other two net service names. If your environment is a clustered environment or environment with the Oracle restart, then we can add a service that is role-based. So here's an example. SRVCTL adds a service for database and service name and role. So I want to start this service only when database role is a primary, or only when database role is a physical standby, only when role is a logical standby, only when role is a snapshot standby database. So you can provide the role for the service. And then we can also add a database. So with the Oracle restart, you can add a standby database, so that way Clusterware or Oracle restart can manage your database and also associated services. Now here's an example of configuring role-based services. So we want to add service called payroll, and this is a primary database role. And also to London database, we have a primary based role. So if a Boston becomes primary, start this service. If a London becomes primary database, start this service. And also enable transparent application failover, so session failover feature. And also, if Boston is running as a physical standby database, start order status. If a London database running out of a physical standby database, start order status. So you can create role-based service. So as you can see, to support automatic client failover, it's best practice to use service. So up to this point, we know a couple of things. In the database level, we can use role transition service to change the database role in case of a planned maintenance or unplanned outage. Now, in order to support application that is connecting to either primary and standby databases, use a service. So that way, client or application can connect to instance where service is running in the appropriate database with the correct role. So there are actually a couple of things that we have to know. In order to achieve automatic client failover, you will have to think about a couple of things. Client time failover, meaning that just like the tnsnames example, list all addresses where service can be running. So Oracle will try with the first address, second address, third address until we can connect to instance where service is running. And also, in case of a switchover and failover, if you are using DB role changes system event, trigger is invoked and also start appropriate services in each database with a new role. If this were a clustered environment, then the fan event is generated and then inform application or client about your status change in the database. So fan is a fast application notification. Typically, Oracle Clusterware CRS process is generate fan message and notify client and application, about this database role change. Now your data guard is configured with the data guard broker. Then data guard broker also publish fan message as well. And also, by receiving fan message, application can take action. So database will get changed. So we have to redirect, application A to new database with the same role, and also redirect to another database with the same role. So in order to control connection redirection, we can use a TAF, transparent application failover, or fast connection failover. So one is a session failover, and the other one is a connection failover. The difference is the session failover, application failover, it takes care of existing sessions. For example, I had a connection to the physical standby database, to the reporting query. If the role the switchover changes database role, the same session will be redirected to a new physical standby database. Same thing for DML. So existing session will be connected to a new database with the same role. However, fast connection failover, it doesn't support session failover. So if you had one session that issued the insert, update, delete, during the switchover operation, the session will be rolled back, and that session will be disconnected, and active transactions will be rolled back. So we have to make connection again, and this time we can connect to database with the same role. And also, we have a transaction guard as well, and also application continuity. Application continuity is another option that we can use. It supports session failover and also it supports DML failover as well. It uses transaction guard to check the status of in-flight transactions as well. So there are many things what we can check. So data guard, broker, and fast application notification. The data guard broker publishes a fan event at failover time. So after the role gets changed as a result of a failover, data guard broker publishes a fan to notify application about database role change. After receiving this fan, if your application is integrated with the Oracle fan event, then application can take action. There are several actions available. One is a fast connection failover, or TAF, or application continuity. There are several options. So Oracle database JDBC, that's an integrated client. And also we have Oracle database OCI and Oracle database.net. The client that receives a fan message, it can be configured for fast connection failover, meaning that your client receive this fan message and then clean up invalid connections to the wrong database with the database with a different role, and then reestablish connection to the database with the correct role. Because the primary database becomes a standby in case of a switchover, standby database becomes primary. So if you had connections to primary database and those connections not valid anymore because of a role change. So fan event, it describes role change, and then application clean up, client clean up these connections, and then reestablish connections to new primary database to support new connection request. That's in a fast connection failover. And client connects to the new database using Oracle Net Connect descriptor configured for connect time failover. In 12C, we have a very nice feature which called the transaction guard. And also we have application continuity. Difference is transaction guard is API. This provide interface that retrieves last transaction commit status. For example, when you look at this diagram, suppose that you have a web application, and then you entered all input value, and then your application issued all database calls that include the insert, update, delete based on my request. And then in the database, we performed the insert, update, delete, and commit. Let's say transaction was complete, but commit complete message never returned. So we have no idea whether my transaction has been committed or not in case of a database communication issue, like an instance failure. In that case, we can use a transaction guard API to retrieve last transaction commit status. And also, what is application continuity? This application continuity, it does one more thing. You request work, and an application issues database call accordingly. If something goes bad in the database side, let's say instance crash, then this application continuity, it establishes the new connection, and then session information failed over to new session, a new connection, meaning that your session can be failed over to new location. And then application continuity, it leverages transaction guard to check last transaction commit status. And this information is saved in the database. So we can easily pull out that information. When using application continuity, it uses transaction guard internally. We don't have to run an API manually. So if the last transaction commit status was incomplete, then application continuity, it automatically replay incomplete transaction behind the scene. So we don't really have to check whether previous transactions was complete or incomplete. We don't have to. So data guard and application continuity. Can I use application continuity in the data guard environment? Absolutely. We can use application continuity for switchover, for failover, or fast start failover with the maximum availability. For example, we have, I have an application and client that connects to primary database. So I issue the insert, update, delete, okay? And then I even issue the commit statement. Now, my database performed the operation, but it doesn't return the result of my transaction if there is any instance crash or communication problem. Now, if application continuity is enabled, application continuity automatically take care of a session failover. But before that, let's say I have a database crash, and also we have the switchover and manual failover. So my primary database, it becomes a standby database. My standby database becomes a primary database. In that case, as a result of a failover, the fan message is returned. You know what? You ran insert, update, delete, and commit, but we don't know what is the final result because of a failover operation. So role got changed. So my application continuity, it looked for the new location, which is new primary database, which was a standby database, and then establish connection, and then retrieve a database to see what was my last transaction commit status. If a transaction was complete, then this new session support continuous transactions. However, my last transaction wasn't complete, then application continuity automatically replay incomplete transaction in the new primary database. So that's available in case of a switchover, in case of a manual failover, in case of a fast start failover. So in the data guard environment, and this feature works. Using application continuity, these are all supported operations: SQL, PL/SQL, JDBC, RPC, select, alter, session, DML, DDL, commit, and it works with the rack database, rack OneNode database, active data guard, and here are the supported client. So in 12.2, 12 and 18C, 19C, over the time, Oracle added a more supported client. So what I'm going to do, I'm going to actually briefly show you demonstration of application continuity by reviewing practice activity. Okay, so I'm in the demo environment. So first practice activity is you will create a service, and you will also use a trigger to start up a service in the correct location. So that's what you're going to test. So we have a service name primary. So it runs only in the database with the database role primary. So in the primary database, we have a service running to connect to Boston database. when you log in as a system user with a primary net service name, and it is referring to a prmy.example.com service, so it will show you current connected to the database instance, which is a primary database. And what we're gonna do, we're gonna create after startup trigger, and then we want to start primary service if a database role is a primary. So we actually connect to Boston database through DataGuard broker command line interface. And what we want to do here, we're going to do switchover to London. If a London the London database becomes primary database, then the login trigger after startup trigger automatically check database role and start prmy.example.com service in the new primary database. So what we're gonna do, you're gonna select instance name from Fidel instance. Now this session was connected to Boston database, and I kept the same session. But after switchover, I lost the connection, meaning that during the switchover operation, it's not possible to keep session by default, because I kept the session and I checked my location of the session. It was Boston, but after switchover, I lost the session. So when you reconnect by using PRMY service, this time we connected to London database. Okay, so it supports new connection. However, it doesn't support session failover. So that's one simple testing what you're gonna do, and then you're gonna switch back. And then what you're gonna do as a part of a practice activity, you will modify primary database service to support application continuity. Okay, we have two required attributes. One is failover type transaction, meaning that I want to enable application continuity in case of instance crash or database role change. Establish a new session to new location, and then fail over not only session but also DML operations as well. And also, if you have an in-flight transaction, retrieve last transaction commit status as a part of an application continuity session failover, and when needed, replay incomplete transaction. So we have to add these two attribute setting. And also, what about in the application side? In the application side, we will have to use replay supported data source. During the practice time, you will execute on one small test application, Java application. It will use properties that enables application continuity. So in the database level, I create service, I modify service to support application continuity. Now in the application level, we have to use replay supported data source, and also we will have to use application continuity enabled service, which is prmy.example.com. And also you will have to use application continuity supported client. In this example, universal connection pool. So in this example, I have a property. I use replay supported data source, not the standard data source. And I use prmy.example to make connection through application continuity enabled service. And also I have a UCP, universal connection pool, which is the application continuity compatible connection pool. So we're gonna run this application. So it makes connection. Okay. I leave this application running, and then what we're gonna do, we're gonna perform switchover operation. Okay. As a result of a switchover, your database is down and restart and change the database role. There are many things going on in the background. Now, when you look at your application, there's no connection error, and you still have connections and sessions without having any problem. No errors here. The only thing what you can see here is you have a small delay for a while. During the switchover operation, this application detected database role change, so it had to wait until your session is failed over to new database, okay, with the same database role, which is a primary role, and then session failover. So it took a little bit of time, but we didn't have any problem. So as you can see, when using application continuity enabled service, and also when you enable application continuity at the application level, your session can be failed over during the switchover operation and failover operation. That's a pretty cool feature. As a part of a practice activity, you will practice this. So I'm going to come back to slide. So as I said, we can configure service to enable application continuity. So in this case, failover type transaction, and also commit outcome true. So one is to enable application continuity, and the other one is to enable transaction guard. Since the application continuity uses transaction guard, the both attribute must be used. So we have some summary of configuring client. Okay, this is something that your application team must review. In next couple of pages, we only have a very high level overview. So this is not to discuss in detail, but just to introduce steps that are needed. Your application team will definitely know what to do. JDBC-thin driver. So ensure all recommended patches are applied at the client, and review support node for application continuity. So how to enable application continuity. Configure Oracle JDBC replay data source. That's what I showed you. Practice 18-2 showed you replay supported data source instead of a standard data source. And use JDBC statement cache for coverage and performance. And turn garbage collector and JDBC concrete classes, and then configure fast connection failover. This is not by DBA team. This must be done by application team. And also, if your connection is OCI driver, OCI client, and same thing, you have to review a client validation metrics for application continuity, and then replace OCI statement prepare with the OCI statement prepare 2, and also to use a fan for OCI based application, you will have to use the advanced queue high availability notification on the service, that's your database side, and also use the recommended connect string for auto ONS, and set auto config and wallet location optionally, and link application with the OS client thread library, and open required port to use your ONS, Oracle Notification Service. So that's for the OCI. For .NET unmanaged provider driver, you review same document, and also you will have to enable fan for OCI based application. Okay, so your application team, you should know that how to use a fan for OCI based application. Okay, so we have a quiz. In a real application cluster environment, which method should you generally use to manage role-based service? And in the clustered environment, definitely we should go with the server control. And fan events are not enabled or started during installation of a grid infrastructure for standalone server for DataGuard. So the answer is true. And next question is, when does application continuity work in a DataGuard environment? The answer is switchover and manual failover, and also fast start failover with the maximum availability. So the answer is A and B and D. This is lesson 18. Practice 18-1, creating and testing primary database services. The first task is you get into host 01 and you're going to set environment variable, and you will log in as sysdba, and you will switch container to deb1 to create service for primary database. In the standalone environment, you will use DBMS service package to create service. And then you're going to start this service, and this service will be available in the primary database in the current DataGuard environment, and this will be running out of a Boston database. Especially it is to connect to deb1 pluggable database. Your listener will recognize newly created service. So when you look at listener status, it will show you primary service. And then we're going to locate host 02 terminal window, and you will set environment variable, and let's log in as system user using net service name, and let's check current location. Since PRMY service it is to start from primary database, your instance name must be Boston database. And the current location is deb1 because primary service, it is to connect to Boston database, especially to access to deb1 pluggable database. And then you're going to return to host 01 and make sure you are in the deb1 container or pluggable database. And then we're going to execute create trigger SQL script to create trigger. And this trigger will be invoked to start service based on database role. And then we're going to use dgmgrl sysdataguard oracle underscore for you at Boston. And then we're going to check current configuration. The configuration status must be normal, success. Now we're going to check the status of a switchover operation for Boston database. And switchover is ready. And what about London database? As you can see, London database is also ready for switchover. And then we're going to perform switchover operation. Since it takes time, I will pause recording and I will return to show you the rest of the steps. Finally, switchover is done. Now let's come back to HostShare 2 and let's check the current location of this session. As you can see, I lost the connection. I lost the session actually. Meaning that during the switchover, your existing session had to be disconnected. And that's the default behavior. But when you make new session, then we can make connection where session 2, the instance where PRMY service is running. And this time it should be London. So let's double check. Connect system oracle underscore for you at PRMY. As you can see, the current location is London. Now, let's say we are in the DEP1 pluggable database or not. Okay, so we were able to use a primary service to connect to primary database, especially to access to DEP1 pluggable database. So I'm going to exit out and come back to DataGuard broker command line interface to validate London database for switchover. So switchover ready. And also I will validate Boston database. The Boston database is also ready for switchover as well. So we're going to switch back to Boston to keep original state. Since it takes time, I will pause the recording and I will come back to complete the rest of the steps. Okay, so finally, switchover is complete. And let's check the status of a configuration. As you can see, now Boston is a primary, London is a physical standby database, and status is good. We're going to keep this DataGuard broker command line interface for the next practice activity. This is practice 18-1. Practice 18-2, modifying the primary database service for application continuity. In this practice activity, we will modify existing service to support application continuity. In the very first step, you will open a terminal window on HostShare 1 and you will set environment variable and you will execute one script to create a table for simple testing. If your table already exists, your table will be dropped and eventually recreated. And we're going to log in as a sysdba and we're going to switch to DEP1 container. And then we're going to execute a script to modify existing service to support application continuity. Especially we need to change it to attribute of a service. One is a failover type, the other one is a commit outcome. And then we're going to execute one small Java application using HCTest replay properties. It includes the replay supported data source and application continuity enabled the service. Application continuity supported the connection pool. So you can review replay property. And then what we're going to do, we're going to use terminal window on host 02, and we're going to execute run replay script. So while the application runs, periodic status message is displayed, as you can see here. So we have an active connection, and response time is 7 milliseconds, 8 milliseconds, and that's what you see. And also, through the primary, using the primary example.com, it makes connection to primary database. Now, meanwhile, we're going to check configuration status using data guard broker command line interface. And then we're going to check if it's possible to switch over at this time. Boston is ready for switchover, and then London is ready for switchover. And then we're going to perform switchover operation. So since it takes time, I'm going to pause the recording and I'm going to resume the practice of recording for the rest of the steps. Okay, finally my switchover is complete. And let's take a look at host 02 session. As you can see, even during the switchover operation, my application was running without having any problem. The only observation is small delay here. And that's the only thing. So my service worked to support application continuity. So once you complete this simple testing, you simply Control-C to stop this application. And as an option, if you want, you come back to data guard broker command line interface, and you're going to switch back to original state. Switch over to Boston. And it's going to take time. I'm going to pause the recording and I will stop. I will return to resume. Okay, so finally, my switchover operation is complete. And I have the error message, but this is temporary error. So when you rerun periodically, you will see correct status. This is practice 18-2.